Hey everyone, and welcome. Today, we're going to dive right into something really important. What makes an industrial balancing machine not just good, but, great? We'll be breaking down the core metrics that really define its performance, and these aren't just opinions. They're straight from the international standards. All right, let's get started.
So, what is it that really separates a good balancing machine from a great one? It's a question I'm sure anyone in manufacturing or engineering or quality control has asked themselves, right? Is it just about the brand name, the size of the thing, the fancy software? Well, turns out the answer is way more fundamental than any of that. It really all comes down to two things, two core pillars that are actually defined by standards like ISO 21940-21. First, you've got accuracy. The easiest way to think about this, it's the machine's eyesight. How well can it see the tiniest little error? And second, you've got stability. This is all about whether you can trust the guidance it gives you. So let's dig into that first pillar.
All right, pillar number one, machine accuracy. And the big question here is, how well can this machine actually see the problem? It really is all about resolution. I mean, think about it. Before you can even think about correcting an imbalance, the machine has to be able to see it. And not just see it, but see it in absolutely incredible detail.
So the technical term for this is something called UMAR. That's UMAR, and it stands for Minimum Achievable Residual Unbalance. Now, I know that sounds like a mouthful, but it's not just a bunch of jargon. This one number is the most important thing that defines a machine's precision. It's literally the absolute smallest, tiniest whisper of an unbalance that the machine can even hope to detect.
Okay, so how do we actually test for this? Well, it's a super precise process. You take a perfectly certified test rotor and you balance it down to the absolute limit. Then you add this tiny known master weight. And the whole test boils down to one simple question. Can the machine's reading actually match the master weight's mass and angle? If it can see that tiny weight and tell you exactly where it is, well, that's your proof right there. This all leads to a really simple but powerful idea. If you can't see it, you can't fix it. I mean, let's make this real. Imagine you're working on a high-speed spindle that needs a G1.0 tolerance. That's an incredibly tight standard. If that tolerance is smaller than your machine's UMAR, guess what? You are never going to balance that part. It's just physically impossible. You can't fix what the machine literally can't see. Okay, let's move on to pillar number two, machine stability. So if accuracy was all about seeing the problem, stability is all about whether you can trust the machine's guidance to fix it, right? Can you really truly trust the instructions it's giving you? And when it comes to stability, there's a huge benchmark. We're talking about a required unbalance reduction ratio, or URR, of over 90% after just a single correction. Think about that. A top-tier machine is expected to get rid of more than 90% of the problem in one shot. That's what efficiency looks like.
But stability is really two sides of the same coin. On one side, you have that unbalance reduction ratio, the URR. That measures the efficiency of a single correction. But on the other side, you have repeatability. This measures the consistency. If you run the exact same test over and over, do you get the exact same reading? Both of these are absolutely crucial.
There's this fantastic saying that perfectly captures what it's like to use an unstable machine. It goes, 越校正越乱. And what that means is, the more you correct, the messier it gets. I'm sure some of you know that feeling. It's that awful sinking feeling when you do exactly what the machine tells you to do, and the unbalance actually gets worse.
And let me tell you, that feeling of the more you correct, the messier it gets, that's not just frustrating. That's poor stability in action. And it's costing you. It's wasted time, wasted resources, and pretty soon you have zero confidence in the final result. It's an absolute productivity killer. So, okay, we've talked about accuracy and stability. We know what they are. But what's going on under the hood that makes them possible? Let's peel back the layers and look at the science that makes these two pillars stand strong. It's really like a symphony of different parts all working together. For accuracy, things like sensor precision and the signal processing, they're hugely important. But for stability, the workpiece support system and the software algorithms become just as critical. Everything has to be perfectly in sync, the sensitive electronics and the super rigid mechanical parts. It's a real balancing act, no pun intended. And deep down, it all comes down to this physical relationship you see here. Now, don't worry about the math too much. Here's what it means. The machine measures voltage and speed. The entire job of all that fancy hardware and software is to perfectly figure out that K value. That K is the magic constant that turns an electrical signal into a physical imbalance. Getting K absolutely perfect, that's the secret sauce for both accuracy and stability.
All right, let's pull all of this together into a final quality checklist. What does a certified machine actually guarantee? What are the things you should be looking for? It really comes down to these 3 proofs of quality. There are 3 tests that are just non-negotiable. First, the UMAR test. Second, the URR test. And third, the repeatability test. If a machine can't pass these 3 with flying colors before it leaves the factory, that's a huge red flag.
So here's the quality promise, broken down really simply. The USMAR test, that proves the machine can see with enough detail. The URR test, that proves the machine guides you effectively. And the repeatability test, well, that proves its results are trustworthy. See, guide, and trust. It's that simple.
And this is so important because that factory certification, it's the bedrock for your own facility's ISO quality audits and approvals. This isn't just some piece of paper. When an auditor walks into your shop, the proven certified performance of your equipment is your #1 defense. It's your proof of quality.
So I'll leave you with this final question. The next time you evaluate a balancing machine, are you just going to see hardware? Or are you going to see the 2 pillars holding up its quality? That's what really matters.